trying to simulate a voltage signal with harmonic content. We will then observe and compare the waveform of the same signal in the three different ways. First, we will do the simulation in KRT software. Then second, we will observe analog signal output in the oscilloscope. And third, we will generate sampled value output for the same signal and then observe them in the sampled value analyzer. Now let's have a look on the physical connections. Here we are using Kingsine's K3163i to generate voltage outputs, which are connected to the oscilloscope probe. We can also see the orange cable, which is an optical cable and which is connected to the sampled value analyzer. And this carries the sampled value signal to the sampled value analyzer. After making physical connections, we will just enter in the harmonic module of KRT software. Once we click the harmonic module, we enter in the main screen of harmonic module, and in the main screen on the right hand side bottom we can see there is a harmonic characteristic, and in that we can select the signals for which we want to see the waveform. So like in this, we have selected VAN and IA, two signals. We have selected two signals just to show the difference between the waveforms when we change and when we add one harmonic component to a particular waveform. Now we are just adding VAN, a harmonic content, second harmonic content of 100%. And you can see that the waveform of VAN has changed. If we further analyze the waveform, in oscilloscope on x-axis, each division corresponds to 4 milliseconds. The total timing of our signal is 5 divisions, hence 20 milliseconds. While there are 4 divisions each of 5 milliseconds in KRT waveform simulator. So in KRT software also, the total timing for the wave is 20 milliseconds. So the waveform is same in the simulation as well as in the oscilloscope. Now in the next part of the video, we will simulate the same harmonic signal using sampled value generator and then watch the waveform in the sampled value analyzer. Later we will do few settings in the sampled value analyzer, and once we will receive the waveform in the sampled value analyzer, we will see that the waveform is similar to the analog oscilloscope waveform and similar to the KRT software simulation waveform. So in this experiment, we have seen that K3163i is capable of giving exact analog outputs with the similar waveform, and it is also capable of generating the sampled values with the same waveform.